Okay, guys, so today we will learn about circular motion. In that particular topic, we will today discuss the angular displacement and angular velocity. What's their definition, what's their formula, and what's the physical significance of that. First, let's start with very simple thing. Let's say you have the angle theta. Let's see how different SI how different units of theta angle uh, are related to each other. So, in degree, we already know. Degree is one of the units in which we count the angle. There is an SI unit which is in the radian. Radian is the SI unit of the angle. And in this circle, we can see that the 360 degree, if you rotate full, it will be covering the whole circle. And in radian, we say it 2 pi. So, in this similar fashion, you can see that pi will be equal to 180, pi by 2 will be equal to 90 degree, and pi by 3 will be equal to 60 degree. You can see the relation between the two. You can find out like what is 45 degree, that is 5 pi by 6, and what is 60 degree, what is 90 degree, and all that. So 2 pi is 360 degree. You just have to remember one thing, or simply you can remember pi is equal to actually 180 degrees. That's the relation between these radian and degree. Now let's talk about angular displacement. So angular displacement is a vector quantity along axis. This is the axis. As you can see, let's consider this as a physical object, let's say a circle, so its axis will be this way, like this. Axis will be here, or maybe a straight line there, and circle is all around it. So which vector quantity is called as an axial quantity? It's A here. So which quantity is axial vector or axial quantity? The vector in which we find the direction of the vector by using the right hand thumb rule. So what is right hand thumb rule? Let's say you move your direction of your right hand thumb. Let's say it's in the above up direction. So if your right hand thumb is in the up direction, if your thumbs are up, then your fingers, in the direction of the fingers at which they are closing, will be the direction of that vector. So if your thumb's direction is up, so the direction will be of the vector will be anti-clockwise. Yeah, so if theta is anti-clockwise, you can say that if the angular displacement is anti-clockwise, then direction will be in the positive z-axis. And just wait a second. Now this is clear. What is axial vector? And angular displacement is actually the our axial vector. It's a dimensionless quantity, and we see this that in the circle angular displacement, we see the linear displacement as our person covering the circumference. Let's find out the how it relates to the simple displacement. So let me make a circle again here, and in covering a full circle, let's say it has radius r, and theta in this case is the angular displacement, and linear displacement is s. Let's say linear displacement is s. So for one full circle, let's discuss about one full circle. If you cover one full circle, how much you will be covering? Let's move to the next page and let's see. First we take the SI units and we write it as in radian. We know SI units of angle are in radian, and it will be this is SI units, and we'll write it in the form of angular displacement, which is in radian. And on the other hand, we have linear displacement. The one which we took, use the symbol S for that. And for angular displacement, we use theta. Let's see the relation. For one full circle, for one full circle, we have 360-degree, and that we know for sure is in radian written as 2 pi. However, for one full circle, the linear displacement covered by u, or we can say the linear distance in this case, the distance covered by will be 2 pi r. 2 pi r. If r is the radius, 2 pi r will be the linear displacement just before meeting up with the initial point. So 2 pi r is the displacement. So if 2 pi is equal to 2 pi radian is in linear called as 2 pi r, so 1 radian, if 2 pi radian is equal to 2 pi r, so 1 radian will be equal to r, simply r, because 2 pi r divided by 2 pi, it will be r. And theta radian, the angular displacement theta radian, then will be theta r. In theta radian, in linear, we can say that the linear displacement S is here is equal to theta r. This is the relation between angular displacement and our linear displacement. You can understand it in a different way as well. We know that angle is equal to arc over radius. This is also one of the relationships. Angle is equal to arc divided by radius, or arc divided by displacement maybe, or the radius in this case. So here as well, theta is equal to S over r. You can see the relation here. Now let's move on to the angular velocity. Angular velocity. Now we know that in linear case, v is delta s over delta t, change in displacement over time, change in displacement by time. Similarly, in the same way, we can say angular velocity is omega. We call it omega. The symbol used is omega here. This is not w but omega. We can say it is change in the linear displacement with time. Yeah, so here omega is also an axial vector. Axial vector, as you can recall, axial vector is a vector whose direction can be found by using the right hand thumb rule. Now its units, let's say the units are, we know that units of angular displacement is radian, and time is second, so radian per second will be the units of angular velocity. For let's say if we want to find out the angular velocity for a particular second, for a particular instant of time, for a very very small time, let's say if delta t approaches 0, you don't want to find for a time period, you want to find angular velocity for a instantaneous time, for an instant of time. In that case, you can say omega instantaneous will be equal to d theta by dt. This is for the, just like instantaneous velocity, this is instantaneous angular velocity, d theta by dt. Now we will try a very important question here. This will be, let's say theta is equal to 2t square plus 2. So now we have to find omega, angular velocity, in 2 seconds. This is the first part. Now the second part is at 2 seconds. At 2 seconds. These are two different things. In 2 seconds means from time is equal to 0 second to time is equal to 2 seconds. Between those 2 seconds, what was the angular velocity? But at 2 seconds is instantaneous velocity. These are two different things. We will see now. You can try it on your own, but let's try it now. Okay, so first part is omega at, we will see how we find the angular velocity in 2 seconds. For that, we know omega is equal to change in the angular displacement divided by the time taken. So we have to use the omega equals to delta theta by delta t. This is what we need to use. But for that, we need to find out the time omega at time 0 to 2 seconds. This is what we need to find for this. So in other words, we find omega average. We find the average angular velocity, because within the 2 seconds velocity will be changing. It will be different at 0 second, it will be different at 2 seconds. So we have to find from 0 to 2 seconds. So we have to find the average. So average means angular velocity at time t is equal to 2 seconds take away minus angular velocity at time t is equal to 0 second. If we do that, then we will find the change in the velocity, angular velocity, and time is 2 seconds only. So yeah, at now you can see that at t is equal to 2 seconds, you can put the value t is equal to 2 here. You can write the value 2 here, then you can figure this out. So it will be simply it will be simply 4 2s are 8 plus 2 10 take away at 0, put t is equal to 0, it will be 2 only, then divided by 2. So omega angular velocity in 2 seconds is on average are 4 radian per second. Now on the second part, here we have to find omega at 2 seconds, exactly at 2 seconds. Remember, in that case the formula was the instantaneous angular velocity was d theta by dt, not delta theta by delta t, because now we are talking about the time which is very instant. So delta t will be approaching 0. So in that case we will have to apply this formula here, and it is simply the derivation. You can simply put the value of theta here, 2t square plus 2. You can separate them out, d over dt, first 2t square plus d over dt, 2. Now 2 is constant, so it will come out, and t square, dt square by dt, so it will be 2t and dt by dt, this will be 1, and plus differentiation of constant is a 0, so it will be 4t. Now it will be 4t, and we need to find at 2 seconds, at t is equal to 2 seconds. So omega instantaneous at 2 second will be 4 times 2, which is 8 radian per second.